Welcome back, ChemStars. It's time to go over the gas laws objective check. So at the top of your page, you have all of your conversion factors. Remember, you should have everything filled in. Right now, we're just going over and correcting it. So we didn't do the in-person outdoor kinetic molecular theory field trip, but in the beginning of the chapter notes, Mrs. Vanderwall went over all those concepts with you and shows you the PhET simulation. So pressure, imagine that you are a moving gas molecule. What is your pressure? It's the number of collisions that you have against other molecules in the container that you're in. The rate at which you walked, that's your speed, that's your energy, that's your temperature. The amount of space you take up is your volume. So let's say this, if we keep everything else constant, if we squish the container down, we make the volume decrease, the pressure will increase. Same number of molecules, push them into a smaller space, they'll bump into each other more often. And question 3, pressure and volume are indirectly related. So if we have right here, if volume goes down, pressure goes up, one down, that's an indirect relationship. Okay, let's look at this problem right here. A balloon has a volume of 2.5 liters. We want to diagram this as we read through. So volume of 2.5, let's call that V1 for right now, and a pressure of 98.6 kPa. Let's call that P1, pressure 1. What is the new volume? So this is what I'm solving for. We're solving for V2. What's the new volume on the balloon if the pressure decreases to 88.1 kPa? So that is my P2. So we know that pressure, we know that pressure 1, volume 1, multiply them together, you'll get the same as pressure 2 times volume 2. So let's go ahead and plug some of these things in. So what's my V1? 2.5. What's my P1? 98.6. What's my V2? We don't know what V2 is. This is what we're solving for right here. And what's my P2? 88.1 kPa. We're dealing with kPa and kPa. I have liters as my input. That means I'll get liters as my output. So how do I isolate and solve for this? I just need to divide each side by 88.1. I'm going to divide by 88.1 kPa, kPa. Remember, no naked numbers. What's going to happen? That'll cancel. And when I rewrite over here, I have that V2, which I'm solving for, is equal to P1 V1 divided by our P2. So take out your calculator. We're just doing some basic algebra here. We have 99.6 times 2.5. Lock that into your calculator. Divide by 88.1. We get 2.82633371. So that's our calc answer. We got to round that for the right number of sig figs. We're multiplying and dividing. That means we need the least total number of sig figs. So if you look right here, I've got 2 sig figs, I've got 3, I've got 3. That means I have to go to 2. That's my least number. So look to the right. Will the 2 round the 8 up? Nope. 2.8 liters, that's your final answer. Okay, temperature is related to the speed or the rate at which you walked. That's the energy that the molecules have. So as the volume of a gas decreases and you keep everything else the same, temperature also decreases. Temperature and volume are directly related. So if volume goes down, temperature goes down. Sometimes that's hard to think about, but we're keeping everything else the same. If you keep the pressure the same, we have to slow the molecules down if there's less space. Temperature goes down. Okay, now we got another problem here. If a balloon has a volume of 4.5 liters, this is volume 1, at a temperature of negative 50 Celsius, this is temperature 1. Now remember, we've got to go to Kelvin, so we can't plug in that negative 50 right now. What is the volume? So we are solving for volume 2 when temperature increases to 0.00 degrees Celsius. This is T2. Now remember, we got to go to Kelvin first. So I'm doing some work over here on the side. So here's my V1, 4.5 liters. To go from Celsius to Kelvin, I've got to add 273.15. V2 is unknown. Circle it. That's what we're looking for. T2 is 273.5 Kelvin. Remember, it's not degrees Kelvin, it's just Kelvin. So here's my equation. V1 over T1 equals V2 over T2. We're going to plug in what we know. So our 4.5 liters, that's our V1 right here. our 273 or 223.15, that's our T1. V2 we're solving for, and we know that T2 is 273.15. How do I get V2 by itself? Do some basic algebra. We've got to multiply this over. So we're going to have in our calculator, so this is how my work goes. So this is step 1, this is step 2, this is step 3, this is step 4. So we're just going to multiply that over. It goes into the numerator, and just plug it into your calculator. 4.5 times 273.15 divide by 223.15, and your calculator answer is 5.508. But how many sig figs do we need? That's the question. Okay, this is where it gets silly with sig figs. So you can't just take the numbers from the original problem. Here we clearly have 2 sig figs. Here you think we have 1, but we don't actually have 1, because if we add that and convert to Kelvin, it's least number of decimal places, and then technically it has 3, and the sig fig should be truncated here, right here. Don't get too caught up in this, but just trust me that we aren't going to pull the sig figs from temperature like ever, because when we convert, we conserve least number of decimals, and just trust me on this one. We're going to go to 2 sig figs. So 1, 2, look to the right. Our final answer should be 5.5 liters. Great. We're done with that one. Have a great day, everybody. Remember, don't wait to be great.